All right, let's talk about a little bit of the work I've been doing. The gentleman I bought the kit from, he didn't do much work except to the torque tube. The design calls for a Delrin block with I guess about a 2-inch Hoare bolt in it that encapsulates the torque tube. And then on the front, you can see there's a plate to keep it from moving back and forth. There's another plate to the rear that's currently not tacked in, but that's what keeps it from moving back and forth. The rear just has the Delrin. Well, he, being a machinist, and a very good one, clearly, he cut the tube in 2 places, installed a bearing, an actual bearing, and then machined up those aluminum blocks to fit the bearing, and then welded the tube back together. There is like 0 friction. It's really nice, nice feel there. The only problem is these aluminum blocks are wider than the Delrin, so if you line up one hole, the other is hanging out into space here. If you try and center them, the bolts go right where these tabs are. So also, he used 1/4-inch bolts for that. I don't remember what the design calls for. Those are AN3 holes, but they might just be pilot holes. I don't recall. My suggestion, if you're building this kit, is those parts, and I'll put in the comments what that part number is off of the plans, but the torque tube mounts, I would suggest modifying them and making them wider. If you use the Delrin, great, but just make this wider and still center it so that it's, add 3/4 of an inch perhaps in width. Go ahead and put the Delrin in if you like, but if you decide to change to bearings, you'll have that width there. That change, clearly is insignificant structurally. It will add, maybe an ounce between the front and back to your plane. Every little bit counts, but that allows you to do that in the future. What I'm going to have to do is make an adapter plate, and I'll talk about that in a future video. The second thing I've been working on is in assembly. This calls for AN3-7 bolts. There are 4 bolts here. There's this one for the front stick, one for the back stick. Actually, there's 3, and then the third one is on the bell crank for the elevators. If you use AN3-7s, actually it's 7, AN3-7 and a nylon lock nut, so 7A bolts. They're too long. If you will notice, when you move it back and forth in the front, it comes out of the tube when it's back, and in the back, when you push it forward, it comes out of the tube in the back. And the AN3-7s, they were sticking out too far here. They were contacting this lip to where you had to kind of jiggle it a little bit, and there was some slight dragging. All of that was unacceptable to me. So the holes in this part here were already drilled, and I don't know if you can see it, but as you can see, it's pretty low in the tube. So my suggestion would be to not have those pilot holes drilled and drill it on assembly, but obviously when you move it fore and aft, it goes up in the tube. Simple geometry there. That low position may be perfect, but either way, I'd suggest not drilling the holes in this gray colored piece here until assembly. But don't drill them too high, because I would hate to lose control authority because I'm hitting the top of the tube, obviously. So my solution is I tested by just cutting a bolt short and using a castle nut. And as you can see, there's no hitting here. Now I don't particularly like cutting bolts. It's certainly acceptable. So I ordered a NAS close tolerant bolt. I forgot the part number. I'll put it in the comments. But basically this is an AN3-7 bolt that's close tolerance, so you have to ream the holes because it's, perfectly 3/16 diameter. But it's shorter. And I don't know if this is, I've got one on, I don't know if it's this one or the one in the back, but that plus a low profile cotter pin nut, and then I'll put a cotter pin in there. But as you can see, nothing's touching. So that was an easy fix, just played around with it a little bit. And these are just stuck in there. They, if I recall, you actually drill and put a bolt in across there. So that's the main work I've done. These strings I put in based on the plans. This is where the rudders are going to be mounted, and this is where the brakes are. Just to play around with clearance. I'm going to be making the floors pretty soon. I most likely will make them out of cardboard per the plans, cut the holes, and make sure everything matches the plans, and then use the cardboard to cut the actual final products out of wood. There are nothing in the plans for throttle. Basically, you're given 2 throttle mounts, and it's up to you to figure out how to make the engine work from back here in the cockpit. First thing I did is the spar goes here. It's in this box assembly here. The rear spar is down here, certainly not in any way in the way for any of this. So what I did is I just took 2 yellow strings and stuck them in for, to simulate control rods to see how low I could go and how it would work for the throttle. The second thing I did is, certainly making a throttle isn't rocket science. I found Aircraft Spruce sells a throttle made by a company called Baxter Throttles, and I'm looking at it. It's about $100 approximately for their standard size throttle, for a 2-lever throttle. And I'm thinking a 2-lever, but I might add a 3rd level for carb heat. I just haven't decided. So on their website they have the specifications for the actual throttle itself. It's 4 inches wide, 3.5 inches tall. I don't know the exact taper, but obviously that's close enough. Didn't have the measurements for the throttle handle and the controls, but I kind of guesstimated them using a known distance. I know that's 3.5 inches tall in the picture, so that's pretty close. So basically what that's telling me is if I use external linkages, I've got plenty of room. Now Baxter allows you to make it where it pivots here, and then your control rods attach within inside this box. Obviously that'll be up higher. The issue with that is this is the trim control as designed. Now that's certainly not going to be difficult to change or modify, but if you have the control rods up here, they're going to be inside the fuselage, and so they're going to be in the way of this. So I've got some work to do to just figure out all this design, but that's why I like cardboard and yellow string. I think that's about it for the work I've done on that. The next is I have been working on this bolts to the spar. This is the aileron bell crank assembly, bolts to the center spar underneath the front passenger's feet, or underneath his seat. The left and right control rods for the elevators go here. A linkage here connects to the torque tube, and when you move the stick left or right, this pivots on this hole and moves your control rods left and right. So I've acquired just about all the hardware I'm going to need for most of this, other than firewall forward stuff. So I've been assembling this and playing around with it. There's a couple omissions in the plans. The plans just show building this single piece. It tells you to build 2, but it doesn't explain in the plans how to put this tube, spacing them and together. It's kind of obvious how it goes, but it was missing from the plans. I talked that over with some people. The bolt, this mounts on the spar, and then this screws up on it, and this goes all the way through the spar. It pivots on that. This is drilled for an AN4 bolt, 1/4 inch. As you can see, 1/4 inch is a bit big. or leaves a little bit there. It doesn't mention it in the plans, but best I can tell, you're to use a bushing. I did some measurements earlier today. That is 1/2-inch tube, 65 thousandths wall, which leaves a 3/8 inch hole. And I found that happens to be a bushing stock that Aircraft Spruce sells. It's a little tight, so I'll have to ream out this hole, insert the bushing stock, and then ream the inside of the bushing to fit my AN4 bolt, which will go through here. That'll probably work. I'm eyeballing the idea of changing this to an actual bell crank bearing or some type of a bearing. You know, I mean, you've got these nice bearings here, but we'll see. I don't know how much difference that'll make versus, you know, the couple hours of work it'll take me to create a new one of these with a bearing. But knocking that idea around. Let's see, a major catastrophe with my kit, if you want to call it that, is there are supposed to be 4 rudder pedals, 2 for the pilot and 2 for the passenger, and all 4 are different. The rear rudder pedals have 3 holes. This connects, the front of the pedal connects to the front passengers, but they're supposed to be bent differently. So basically I have, and somebody labeled one of these right hand, so I have 2 right front pedals and 2, I'm sorry, these are the rear pedals. I have 2 of those, and I have 2 of the front right pedals. So I need to, certainly not going to bend that 180 degrees, that's just not good. So I need to make some new ones. Clearly not a big deal. Not rocket science making those, and they're clearly drawn out in the plans. I was talking to a colleague of mine building one of these. He actually drilled these out bigger, inserted some, I think it was bronze tubing, and then filed it flush for bushings. That way when they wear, he can press them out and put in a new one. And he's doing that wherever he can. That makes a lot of sense to me, because that way if it wears, you punch out the bushing, punch in a new one, and the wear is gone. A little bit of filing, and you don't have to remake this part. Not that it would take that long to remake the part, but so I'm looking at that. Certainly don't need bearings or anything complicated on these. These are the rudder pedals. They just hinge. There's some Delrin bushings pressed in, and then a big long AN3 bolt goes in there. So just doing some test fitting on things like that. That's pretty much where I am with the kit now. I'll do another update fairly soon. Thanks for watching, and talk to you guys later.